So, question for you. If you burned 1 gallon of gasoline, which is approximately 2,850 grams of gasoline, how many liters of CO2 would be produced at a temperature of 20.5 degrees Celsius and 757 millimeters mercury of pressure, given the balanced chemical reaction below? Let's try to figure that out.
Okay. My pressure is 757 millimeters mercury. So I can times that by 1 atm over 760 millimeters mercury. And remember, this is an exact conversion, so it will not limit our sig figs. And I get 0.996 atms. Also, the temperature, we're given Celsius. I need to convert that into Kelvin. So I add these two together, and I get 293.6. And remember, this is to the first decimal place. And so according to the addition significant figures rules, the final value also needs to go to the first decimal place. Okay. The volume, we don't know the volume yet. That's actually what the question is asking. The liters is in volume, so we don't know what the volume is. And our number of moles of gas produced, well, we're going to have to use some stoichiometry to figure that out. In order to do some stoichiometry, first, right, we have to use this balanced chemical equation. Okay. So we start out with 2,850 grams of gasoline, okay? So, start out with 2,850 grams of gasoline, and now we need to figure out how many grams are in 1 mole of gasoline. So, I can look up the molar mass for carbon and hydrogen, right, on the periodic table that we have, okay? So then, 112.01 times 8 equals. All right, so I got, what'd you get for the molar mass for 1 mole of gasoline? I got 114.26 grams, okay? So then grams of gasoline cancel out with grams of gasoline. Now we have moles of gasoline. So I write moles of gasoline on the bottom and moles of CO2 on the top. Now, where do I get these numbers from? I know I need to put some numbers here. Where do I get these numbers from? Yeah, the balanced chemical equation. So, moles of gasoline, I look up here, there's 2. So 2 moles of gasoline and 16 moles of CO2. So 16. And then moles of gasoline cancel out moles of gasoline. Now we're left with moles of CO2, which is what we wanted. Okay, so now we just do a little bit of math. Multiply across the top, divide by the bottom. So 2,850 divided by 1,4.26. All right, so I got 199.544. But I see, let's see, this is an exact conversion, so unlimited sig figs. Right here, I see 5 sig figs, but here, there's no decimal place, so this 0 does not count as a significant figure. So 3 sig figs. So 3 sig figs, this should be 3 sig figs. And let's go ahead and round that up to 200 period moles of CO2. So now we can write that right here, 200 period moles CO2, all right? And so PV equals nRT. We're looking for the volume. So now we can rewrite this. We divide both sides by the pressure. So I get V, volume, is equal to nRT over pressure. Okay? So now let's go ahead and plug in all these values. So 200 period moles of CO2. Okay, times R, 0.08206 liters times ATM over mole times Kelvin, right? And then times the temperature, which was 293.6. 293.6 Kelvin, and that's all divided by the pressure of 0.996 atm. Okay, so then let's cancel out our units. So mole divided by mole, Kelvin and Kelvin, atm and atm. We're left with liters. Good, which is what we're looking for, okay? So the volume will be equal some liters, okay? So let's see, 200 times 0.08206, okay? All right, I got 4,837.9 liters, okay? But I see 3 sig figs, 4 sig figs, 4 sig figs, 3 sig figs. So 3 significant figures, 3 significant figures. Oh, 3 significant figures is the least number of significant figures. So our final answer also has to only be 3 significant figures. So that'll be 4,840 liters of CO2. So that's 4,840 liters of CO2 from just using 1 gallon of gasoline. From that much CO2, that many liters of CO2 from 1 gallon of gasoline.
Whoa. So we just calculated out 4,800 liters of CO2 produced from just 1 gallon of gasoline. Okay. So I don't know how many miles per gallon your car gets or your truck gets. Okay. But let's say you drive around and you burn up, you use 1 gallon of gasoline. Okay. And then your vehicle produces, right? You just produced 4,800 liters of CO2. Now let's think about that. What's a liter? This is 1 liter of volume. Okay, this is my Nalgene bottle, right? It's 1 liter. So, right, this is just 1 liter. Imagine 4,800 liters of CO2 produced just from driving around and burning up 1 gallon. Just 1 gallon of gasoline, right? Just one person in their car driving around, just like me. Okay, I drive around, right? Go grocery shopping or whatever. It's easy to just burn up 1 gallon of gasoline, right? And in doing that, in burning up that 1 gallon of gasoline, I make 4,800 of these of CO2. Wow. That is a lot of CO2. Am I right? Wow.